Hello, everyone. Thank you for joining us today for continuing third part of our SES New Faculty Introduction series. We're going to be taking questions from attendees in a few moments, but first I'd like to introduce our two new faculty today. First, we have Melissa Orto Martinez. She comes from us from Stanford, where she completed her PhD in mechanical engineering, and she's now here at CMU running the Social Haptics Robotics and Education Laboratory, or the SHRED Lab, which is awesome. And even before she was working on her PhD at Stanford, she was actually at Apple for 3 years, working in the Human Input Device Firmware Group. And also joining us is Nitin Martelargo. He graduated also from Stanford with his PhD in mechanical engineering, and in general sort of explores the future of design processes and how to augment a designer's capabilities with new technologies and new design methods. And that has applications in a wide range of areas, including human-robot interaction, autonomous cars, human-centered intelligence, and so on. So great to meet you, Professor Martinez, Professor Martelaro, and we will turn it over to watch some introductory videos.
Hi, my name is Melissa Orto Martinez, and I'm a new assistant professor here at the Robotics Institute at Carnegie Mellon, and I'm also the head of the Social Haptics, Robotics, and Education Laboratory. And in my laboratory, we're very broadly interested in researching haptics and robotics with a focus on social problems and developing educational technology. So today I want to tell you a little bit more about the work that I do. And just a heads up, my cat named Lila is on my lap, so she might pop up and be a guest star of this presentation. So first, let me very briefly define haptics and why I do the research that I do. Our haptic or touch sense is the largest in our body. It comprises all of our skin as well as mechanoreceptors in our muscles. It provides us information through our skin about temperature and textures, but it also enables us to move. So for example, if I lift my arms up, I can touch my fingers up above my head without really having to look, thanks to all the mechanoreceptors in my skin and my muscles that tell me where my limbs are in space. So as you can probably tell, our sense of touch is very complex. It's involved in almost everything we do, and there's still a lot of open questions about it. Questions about exactly how it works, how to best design devices for it, and the types of applications that will benefit from adding our sense of touch. Just to give you an idea of what is possible right now, here's an example of a kinesthetic haptic device interacting with a virtual dessert. As the user moves the cursor around, the user can feel forces as if they were interacting with the dessert through some type of pen-like tool. So just to be clear, the user won't quite feel the moisture and the richness in texture of the dessert, but they will feel the stiffness and the dampening as if they were interacting with it and all those forces, but through a tool. And the reason for designing devices in this way is that trying to mimic the richness of our sense of touch is not really complicated because of all the mechanical constraints, but also our sense of touch is not quite fully understood. And in order to understand just where we are, I like to give a comparison to vision. So our sense of vision, I would say, is quite well understood. Physiologically, we have 3 cones in our eyes, and they each sense light at different frequencies of red, blue, and green. And we understand how those frequencies of light get combined to give us all the other different colors that we sense. And not only that, but we also know how to decompose images into those colors and into those frequencies, so that now we can just feed into computer images as just a weighted array of numbers, and then the computers can basically do our work for us. And that's why the field of vision has exploded, and there's so many different applications on it. And touch, we're not quite there yet. We do understand the different mechanoreceptors that are in our skin and in our muscles, and they also behave like bandpass filters, acting mostly to a set of frequencies. And on the other hand, from materials that we touch, we do understand kind of the classification of materials and properties of it, but we still don't have that mapping. We can't say quite yet how to go from, running my fingers through a piece of wood or something, it's going to be 20% this signal and 30% that signal, and then how to play that in some type of haptic TV so that we can render all of these richness that we feel in the world. Then like even with all those gaps in knowledge, there's still a lot we can do. And the sense of touch has proven very beneficial for a lot of applications in medical training, in surgery, in rehab, in gaming. I mean, we all have our phones with touch in them, even to try and improve car safety. And so for me, the application that mostly motivates me and I'm most passionate about is education. And the reason for that is that in the very early stages of learning, we use our sense of touch constantly to explore and learn. However, at some point, we decide that this should be our learning model. And because of the way we have decided that we should learn, there's been very little research conducted into how our sense of touch helps us learn. And so as an engineer, I approach this problem by focusing primarily on designing these haptic devices, both very low cost open source haptic devices that are specifically designed for educational applications, as well as developing new soft tactile actuation technologies that can allow us to better understand the capabilities of our complex sense of touch. So trying to get at that RGB mapping that we have for vision, but for touch. I also focus on designing educational environments that use the sense of touch in order to study and understand the capabilities of the sensory modality in education. In this example that you're seeing, for example, students can interact with trigonometric functions through the sense of touch. So feel those functions and explore them. And they can feel the changes in amplitude and frequency as they change the equation and function. And we have conducted studies with high school students in which the graph of the equation is hidden from them. And then through exploration, they can understand the feel and understand the different changes in the equation and actually draw those equations. Another area of my work is just designing educational technology in general. This is an example of a device that allows very young students to combine finger movement and math learning. And the reason for that is that it has been proven that finger gnosis for very young children aged between 4 and 7 years of age is actually correlated to math ability. And that improving that finger gnosis or finger perception can actually improve math skills. So I designed this device to further study this phenomenon, as well as to research how we can deliver to these very, very young students personalized educational experiences. And so finally, I just want to thank you so very much for your attention, and please don't hesitate to contact me if you have any questions. Thank you.
Hi everyone, my name is Nick Martellero. I am an assistant professor here in the Human-Computer Interaction Institute in the School of Computer Science. My research is primarily around understanding what designers do when they do their work, and then thinking about how we can better support them in doing their work, especially as they start to design more interactive and autonomous systems. So I'd like to show you a little bit of the work that I've been doing, developing computational tools to support and augment designers in the work that they do. My personal background is that I come from an area of building mechatronic and interactive products. I've built things like robotic couches, interactive smart materials, data collection systems for automotive driving environments, as well as interactive and smart speakers. And what I'm really interested in terms of my research question is, how will designers create future interactive and autonomous systems? And the way that I approach this with my research is that I build design tools and I study how they influence design processes. And what I'm really motivated by are these sort of future-looking interactive and autonomous technologies that we're starting to hear about much, much more today. Things like autonomous cars, personal robots, and digital assistants. Now, all of these pictures here are products that are available, and these are all really beautiful kind of shots of what the objects look like. However, I'm really interested in how is it that these objects are going to behave with people. And I'm really motivated by this quote from Terry Winograd in The Design of Interaction that talks about successful interaction design requiring a shift from seeing the machinery to seeing the lives of people using it. And so much of my work is really focused on understanding people, seeing people, and then trying to do really human-centered design of new interactive and autonomous technologies. So let me show you some examples of my work that kind of highlight this. The first set of projects I want to talk about are systems that I've built to do remote observation and interaction prototyping of new autonomous systems. So one example here is I built a system that would allow user researchers to remotely observe and interact with drivers as they were using partially autonomous vehicles. So for example, this driver here in a Tesla, completely hands-free, they're actually yawning. And in the background, I'm actually talking with them about what is their experience, what are they paying attention to. And we actually ran a study where we had a number of drivers drive basically partially autonomous vehicles, and we really understood what that in-seat experience was. Now, this was really great for our partners that we were working with Renault and Nissan, because currently they really don't have a lot of ways to understand what that real lived experience is. So these kinds of remote sort of Internet things driven observation systems can be really powerful in helping designers to actually understand what these technologies really look like when real users are sitting in that driver's seat, when these things are out in the real world. Now, one of the other exciting aspects of my work, and this has actually become a little bit more important recently since we're now all working basically from home or remotely, is that all of the systems that I've built for this actually allow designers to work in a distributed fashion. So they can interact with people either in their home environments or in environments like their own cars, but they can be anywhere in the world. We've actually been able to have numerous designers log in from anywhere in the US or really anywhere in the world to actually interact and observe users trying out new technologies and to prototype new interactions. So in terms of that idea of prototyping new interactions, so we of course can observe and see what it's like for people to use currently available technology, but I'm also really interested in seeing what could new technology look like and how are we going to actually test new ideas in a really rapid and agile manner. A project that I did with Spotify actually looked at this in terms of speech interaction with music agents, and they were really interested in understanding what would it be like to talk to your speaker in a more meaningful way about your music rather than just say commanding to play a song, but what if you were going to talk about the songs you like, the songs that you remember from when you were older or when you were younger. The other thing too that we've been able to do in terms of this sort of remote observational work is that we're able to push into environments and explore new technologies in places that we might not be able to reach normally. So for example, I've been recently doing a lot of work on a farm in upstate New York, all of this being remote, where we're actually observing tractor operators who are working with semi-autonomous farm equipment, or in this case, as you could have maybe seen in this video, fighting with semi-automated equipment. The other area of my work that I also look into in terms to support designers, not just with say observational or prototyping tools, is also providing ways to assist designers in more say cognitive tasks. So to help them basically in their design thinking. I have some really new work that I've been conducting around computational design assistants that can actually sit with a designer and ask them questions about the design work that they're working on. And the idea here is really to push designers' thinking into new directions that they may not have considered before. I'm doing this work in collaboration with some researchers at Accenture Technology Labs. My colleague Charles Foster is here. And we've actually developed a system based on some of the more advanced AI language models, specifically OpenAI's GPT language model, to generate designerly questions or the kinds of questions that you might ask in a design session or in a brainstorming session. But in this case, it's actually a computer doing that. So for example, we have a sample here about asking about an autonomous car regarding safety. And I like the fact that it actually asks some questions that are, maybe like when is the best time for a non-autonomous driving initiative or incentive program to come to effect? But it also asks, maybe some provocative questions like, is it really the kind of technology that will make anyone safer? The interesting thing here being this is completely computer generated. And while all the questions may not be the most sort of well-formed questions, they sometimes can actually lead to designers thinking in new ways. And so that can really kind of spur creative thought. So overall, I'm really excited about a number of areas in supporting how we design new interactive and autonomous systems. The three areas kind of together that I like to show of my work are really design methods and tools, interaction design, and autonomous systems. And so I'm really excited to talk to others about this, and feel free to reach out to me if you'd like to know more.
Okay, that was a great overview. So we're going to kick off the Q&A component of this new faculty session. And I'll start off with a question that I have that I'm curious about. So, mechanical engineering is obviously very much about understanding and designing mechanical systems, but both of you focus a lot of your research on understanding humans. So I'm sort of curious how your PhDs in mechanical engineering brought you here to the School of Computer Science. And Melissa, why don't we start with you?
Sorry, just too much doing weird things. Yeah, so I feel like at the end of the day, as a scientist, there's always underlying motivations that people have. And so for me, I am really, really motivated by trying to aid people in their learning. And that's why I really want to, even though I am selfish in the way that I do still just like solving interesting problems and researching mechanisms and building mechanical systems. But at the same time, I'm also very motivated by just seeing how it is that these mechanical systems can interact with people and help them learn. So.
Yeah, and so I think for me, a lot of the actual education that I had when I was an undergrad really was focused on human-centered design as a way to really approach engineering education. I went to an interesting undergrad college called the Franklin W. Olin College of Engineering, which was like an entirely project-based course program. And everything was always really user-driven. We were always, we always had some type of stakeholder or user that we were always working with. And I think that that really shaped a lot of my thinking. But the other thing for me too is that I actually find that even in mechanical engineering, where we were learning all of our technical kind of product development, we were always thinking about okay, this product's going to be used by someone, and so I ended up just getting really into that. The other thing for me was that I always found that I got my best ideas when I was really in conversation or when I was observing people or learning from people. Stepping into their shoes and things. And so I really derive, a lot of energy and sort of ability to be creative myself, from actually working with and seeing people. And so that's kind of how it overlaps. And then here at CMU, right? I mean, for us here in the HCII, right, this is like core to the program, which is one of the reasons I was so excited to come here.
So on a related note, and Nick, we'll start with you on this one, is what do you look for in a colleague that sort of best complements your background, and maybe also PhD recruits as well? Is there someone you mesh with really well?
Yeah, so I generally find like I can work with lots of people. There's a couple in terms of a lot of the collaborations that I have and the ones that have been really successful, they kind of break down in a couple categories. Sometimes I work with people who are super technical and are bringing in a technical capability, and they're actually working with a technology that both of us think can be applied to design work, to the way that people kind of create things, and that they maybe have a lot of that deep technical expertise. And I'm bringing in a little more of that understanding of design process, and we work really well together. So for example, I had mentioned working with my colleague at Accenture on some of the computational question generation. So they actually have a pretty good knowledge of these NLP systems. It's not my background, but we've been able to work together really well to actually generate a system that is quite interesting. The other thing too is I think is people who build. So a lot of my stuff is about building things, getting it out there and getting in front of people. And so anyone who is really excited about building stuff, especially with students, I always find that the students who I seem to work well with are the ones who are always excited to jump in and start, trying something out, and then having that really guide and shape their thinking, and then help them kind of really, dive into sort of some of the more theoretical and kind of interesting background stuff, but that they're always trying to put that stuff into practice.
So Melissa, how about you? What kind of colleagues or students do you get most excited to collaborate with?
I feel like for me, it's really about people who are very passionate about what they're doing, and who are also just in general, what I would consider a good person who is very invested in you succeeding and and then they're very reciprocal to you wanting them to succeed. And so then then it's very easy that way to find a middle ground and to find something that really excites both of them, and then both can be successful.
So a bit more of an oddball question, but I'm sort of curious of, all the research that you've done in your thesis work and now at CMU, what's sort of the strangest or most surprising thing that you've created? Is there some sort of oddball that you've tucked away into a closet or a surprising research result? So Melissa, what's on your history?
For me, I think so. Like one of the things I really liked about Stanford was just all the people that were around that you could just do weird things with. And so yeah, part of my work was my PhD work, but then also I was just really interested in just discovering things and materials. And so one of the things that I'm actually pursuing now with my student, because it was a project that I started, but I never published on it or anything because it was just a side project, was just in using silly putty to give like different haptics effects and different actuation things. And it's just really cool.
For me, the like most oddball thing I'd have to say is probably you saw a little bit of that, the kind of robot furniture work. It's not actually my main area. That's a lot of my advisor, Wendy Ju, is really interested in that. I just ended up building a lot of the physical systems for it. So because I was interested in it. It's an area that I've been lightly looking into kind of continuously, is this area of robot movement and actually how robots, how their movements can actually evoke different reactions and responses from people. But it's sort of this, it is this weird thread of work that I don't actually talk about a ton. I will say I do have some new work where we've been developing with, I have a student over in mechanical engineering who's working with me where we are developing, it's actually like this little puppet. And you can actually remotely control this robot puppet. And we're actually going to be like shipping this out to people's houses and then having it like not dance, but like act in front of them. We're going to try to see like what happens if you have something that moves really weirdly or something that tries to move like really maybe beautifully or smoothly, and like how do people respond to that? So that's kind of some of the more oddball stuff I have.
Okay. And I'm sure you'll be making more oddball stuff in the near future when you get back into your labs.
Yeah.
So we have a question from our attendees, from Katie. Now she's asking if you can comment a little bit on how you've been teaching this year. Are you using kits of hardware or teaching mostly software? And how have you been generally handling the pandemic with such hands-on research areas? So Nick, why don't we kick it off with you?
Sure. So I actually teach a class on rapid prototyping of computer systems, which is a big product service system course. And students come together from electrical engineering, computer science, HCI, mechanical engineering to build a mostly like an Internet of Things based system to support a user. In this case, we're working with to try to improve the quality of life for those with Huntington's disease. It has been challenging. I think that being fully distributed makes teamwork a little bit challenging, and at the same time, I do think that we are all starting to learn. And one of the things that I'm excited about for the students is that they're able to start to learn how to act as an effective distributed engineering team, because I think that's going to be a skill that is going to become more important. In terms of kits and parts, we're actually having people order just like they normally would, and we're just shipping it to them. But we do have an infrastructure system, and one of the teams is really working on this to make sure that all the things communicate with each other. That's one thing that we're really focusing on this year. But yeah, I mean, actually parts and hardware has been something that they can do because a lot of the students have been pretty resourceful.
Melissa?
Yeah, so I'm teaching a class on haptics, which if you don't have anything to touch is pretty meaningless. So yes, I designed a device that's basically a kinesthetic haptic device that can be built by students. All the parts are 3D printed, And so I actually did not know about the different CMU resources. So I did 3D print all the parts myself in the basement and just shipped them out to the students, and I shipped them out their electronics boards. And so, but they built their devices themselves. And it's also a device that can transform between different degrees of freedom. So then they get to learn kinematics and dynamics and whatever the math that you need to learn in order to be able to render these virtual environments. And we then transform them into 2 degrees of freedom. We also have a very fun lab in which students actually learn how to do teleoperation. And so they can simulate kind of the controllers and mathematics that you would need to do, for example, like remote teleoperated surgery, for example. And they get to control their partner's device from their homes safely, and their partner's is in remotely in their own house. So yeah, luckily I was able to make that work, but it's definitely been a challenge. I've had 2 students whose device broke, and so I had to, bring the devices to my house, fix them up, and then ship them back. Normally in a lab, you would just be able to go around and teach the students how to fix them up themselves. But yeah, I mean, it's definitely been good.
So just to follow on from that, when you're back in your physical classrooms, hopefully next teaching semester, how will your classes be different, or what are you going to hope? Like, what's sort of the vibe that you love to see in your physical classrooms when you're face to face with your students and working hands-on with these sorts of technologies? So Melissa, you want to continue?
Sure. Yeah, I think the huge difference for my class is that normally what I would love is for there to be a very large group project component to the class. This time I reduce the level of the requirements for the project a lot, because I know it's challenging, and people have different levels of what they feel comfortable with in terms of going to a workshop and building, etc. And so, but when in person, what I would love is for students to build their own haptic devices and their own haptic applications. Right now, we're just mostly expanding on the device that I gave them. So that's what I really love. More collaboration. Yeah.
Nick?
Yeah, in terms of the vibe that I would want to create is more of a, I want my classes to feel like design studios. And so that studio environment where, you feel like you can work together, that you're actually working on through a variety of mediums. So, you've got physical, you're on a whiteboard, you're maybe working with paper or something you've drawn out, some physical sketches. The students we've been trying to recreate as much as we can in kind of digital environments, but I'll say it, I miss being able to post something on a board and sketch something out on a board. So we're making do, but that's really the kind of feel that I want, is that students are really coming together. The other thing too is just also being able to kind of overhear students. I think I'm looking forward to the students being able to also overhear each other while they're kind of working in their sub teams, because then someone goes over and says, oh, hey, actually we're talking about that now, or we should think about how we're going to integrate, these 2 subsystems that we're working on.
Okay, well, I look forward. I wish I could join both of your classes. Sounds like a lot of fun. This is another question from one of our attendees is, how will you personally contribute to efforts to make the university a more diverse and equitable and inclusive place? And do you have any recommendations or relevant experiences that you'd like to share? So why don't we start with Melissa?
Sure. Just as a background, I think for me is that I come from Mexico. I was born in Mexico City, and I came here for school, and then I stayed. And so the reason why I came here was because of how inequitable Mexico is and how little opportunity there are. And so I definitely came here with the naive thought that I was going to go to the US, make a lot of money, come back to Mexico, and build a ton of schools. And so now I realize that the way you live your life also matters. It's not just about making a ton of money, which is why I focus my research in education mostly, and using engineering to improve education. So for CMU in particular, I'm very involved with outreach activities, and I have been throughout my life. And so I want to bring those to CMU as well. I want to make the admissions process, especially in the Robotics Institute, and I don't know if I'm going to get in trouble for this, but I'm part in the Robotics Institute, and I would like to see the admissions process be more equitable there. And by having a wider diversity of students and by giving them the opportunity, I believe that that the environment of the university can definitely change. Of course, it's not just about that, I am very happy that now there's going to be a diversity, I don't remember the right word, what the title is called, but like a diversity dean person. I'm also an organizer of a diversity and equitable inclusion seminar series that is going to start in April. But yes, I mean, definitely diversity, equity, inclusion is at the forefront of everything I do.
So Nick, any thoughts?
Yeah, so for me, a couple of the things that I've been doing and being a part of is that we actually have a number of committees that are been formed around diversity, equity, and inclusion. I've been working closely with one of our committees, our Black Lives Matter committee. I've also been a member of the admissions board as well. And like Melissa, I agree that I think that we can make a lot of change in how we sort of admit students and thinking about what, who's going to make a great CMU student. And also, how do we kind of reach out to great students who are in all kinds of places, in all kinds of situations, and from all kinds of backgrounds. So that, for me, I think a lot of it has been about getting involved. And this is something I guess like as a recommendation is that there are opportunities here at CMU to get involved. And so, taking those opportunities and stepping up and volunteering has been really important. The other thing too is I also have been trying to approach this in some of my research. So from an inclusion perspective, I'm actually leading a project right now on inclusive design for autonomous vehicles for those with disabilities. And I've been working with some other amazing faculty members, Patrick Carrington and Sarah Fox. We actually have a big project. We're working with a ton of students where we're trying to design better ways or new ways for those with disabilities to communicate, control, and take independent rides in autonomous vehicles. And as part of that, we've also been reaching out to the local community here. We have a lot of community members in the Pittsburgh disability community and traffic advocacy community. And so we're also thinking about how we as CMU kind of can reach out to our local community and kind of also bring those community members in to participate in these type of activities.
So maybe on a somewhat related note, talking about the student body is, you've now completed your PhDs, you're in this faculty mold. How do you see sort of the nature of PhD programs and elite institutions like CMU evolving? I mean, over the next 10 or 20 years, your research careers, your academic careers, do you see the notion of what a PhD student is evolving, and where is that going? So Nick, you want to take that?
Sure, that's a really interesting question, right? It's very like to think kind of forward in that. I mean, I think there's going to be a lot of things that are still similar in that, I mean, I still think that for those who want to get a PhD, right, they have some deep drive to kind of work at the forefront of knowledge, to build and to grow knowledge. Also that they are really interested in, and I'll say that maybe this is my own bias, but like a lot of PhDs are kind of people who want to do things their own way, and they want to do things, they think that they can do things differently. I really value that in students. Actually, to me, that's like one of the biggest markers of what I think is going to make a successful student, is someone who's like, I have ideas of how I think I can build new knowledge to do things differently. And I think I can do that by doing a PhD, as opposed to say going in an industry, because I will say that there's a lot of really amazing, innovative stuff happening in industry. I work a lot with industry. I think that what's going to be interesting going forward is that connection with also real world application. I think that we're going to start seeing a lot more, at least I know in my lab, that's one of the things that I'm going to be pushing, is a lot more connection between the research that we're doing and then how we're actually making an impact and a connection into the real world, to everyday people's lives.
Melissa, any thoughts?
Yeah, I want to just build up on what Nick said, because I agree with him. I think the big change that I see that I'm extremely excited about is that I believe that back in the day, how do you say, the impression of academics was this, this old guy just stuck in a lab, just doing something. But the new students that I see are very much I'm really worried about climate change, and I want to make a difference in the world, and I really want to get out there and do something. And so that's where I see more the opportunity of a PhD now, in being what can you do if because in a company, the incentives are very different. Like the incentives are, okay, which is very valid, but you have to make a product and you have to satisfy your board and your customers, etc. But with a PhD, it's like, okay, if you have this money now, like how can you change the world in a positive way? And so that's what I'm very excited about seeing.
That's a great answer. So picking up a little bit on what Nick was mentioned about engaging with industry, which is another conduit to have, real world impact. What sort of applications do you see in the kind of short to medium term from your research over maybe the next 5 years? Like, what are the ways that you can reach out and have that industrial impact as well? So Melissa?
Yeah, so for haptics, it's been said by many CEOs, like the Microsoft CEO, that it is the next big thing, the next frontier. Whoever can crack it, and now imagine that you can have, augmented reality experience, but actually feel the things that you're experiencing, right? Like that's the next big thing. There's a lot of barriers to get there, but I do think that once, like right now we're writing a big proposal for an ERC so that we can actually get a bunch of different perspectives together and try to crack this problem, because it's a huge problem, from understanding the psychophysics, the psychology, to how to design these devices, to the fact that because there's not that killer application yet, simply the way we design these actuators, we don't have the right materials, et cetera, et cetera. So I do think that there's so many applications that haven't even been discovered, but definitely in AR, in just anything that you can think of doing at a distance, you need the sense of touch to be able to do it. So remote surgery, social touch, anything. Like we were talking about, for example, a person that was really excited with the pandemic was a meat factory where like the workers cannot be close together anymore. Can the workers be at a distance safely? And now like robots are doing it, but a person is teleoperating those robots. Autonomy, really, of course, autonomy can get you a lot. However, it's not quite there yet to be able to have the dexterity and the thought process that we as humans have. So you need a human operator. Now, how do you have that human operator actually be dexterous at a distance? You need the sense of touch for that. So,
Nick?
Yeah, so I think in terms of impact and industry applications, I have in the short term, I think I've been exploring a lot of things around speech and proactive speech interfaces and interaction. I think speech is becoming more common, but I still don't think that we're there yet. It's mostly just a lot of interfaces are really just command-based. It's a sort of, a speech-based button. It's you're pressing a button of sorts, please start the music, set a timer. I'm actually really excited though for like a future where people are actually, and designers are really figuring out a much more, systems that are proactively speaking with you, systems that are talking to you about kind of more meaningful or more interesting and complex things, and then how that can actually be used. In the longer term, I think that recently a lot of work that I've been getting into has been around how to engage more users and more stakeholders directly in design processes. And I think that as we start to see kind of new technologies get developed, and the fact that today many companies are much more in the spotlight for, say, the social implications of their technologies, that having a more participatory design process where people are much more engaged with the design of new products or services, I think is going to become more common. And I actually think this is an area that, a lot of people haven't entirely, figured out. I think there are tons of ways, we know so many ways to engage users, but actually to engage people broadly, especially as we start designing systems which are so widespread. I'll say a lot of I've been doing a lot of work recently where we're engaging at like city level service design, like thinking about how new autonomous systems are going to be running around our sidewalks. How do you engage a city in that design process? And that's something I think from a longer term perspective, like our research now that we're doing could potentially help influence how companies, municipalities are going to be doing that stuff in the future.
So maybe on that note, since you're at the start of your careers here at CMU, but let's say 5 or 10 years down the road, you have a hand in creating a new department inside the School of Computer Science. what do you think that new department's going to be? I think the most recent one has been computational biology, and obviously we already have human-computer interaction and language technologies and robotics and machine learning and so on. What's that next big thing? So Nick, you want to take that one for?
Sure, I'll try. That's really, I mean, it's interesting that you say that, because I just watched this this little video about like the history of, it was like a history of the HCII, and how, right, the HCII is a new department, right? Was years ago was a new department, then it came together, and the fact that CMU does this, right? Like they're completely fine and I was actually really inspired by that. So it's a cool question. I think one of the things that potentially could be interesting is really a department of, I'm going to build off my answer here. I'll put a stake in the ground, and and then, yeah, 10 years from now, when people watch this, they'll be like, you didn't know what you're talking about, which is fine. I think that there's something around large scale socio-technical design. And so in a way, it kind of, if you think about it, it's sort of a mix almost maybe of like public policy, engineering, computer science coming together in the same way that HCI and is going to bring in. But there's so many more things that are going on that even, for example, the departments we have, I don't think are integrating as tightly. So these are things going to be around legal applications, policy design, this kind of stuff. And there are other faculty here who've been thinking about. I know actually John Zimmerman, I remember talking to him about this. He's really interested in like policy design. Sarah Fox is really interested in this. So yeah, something like that, like population level socio-technical system design.
Okay, we'll hold you to that, Nick.
Yep.
Melissa, what do you think?
Yeah, I'm thinking it's a really hard question, but I'm thinking that for the future, and building up on the answer that I had given before about the types of students that we're getting and what they're interested in, I think that we really need a department where people come together and work on interesting problems that are affecting the communities around them. And so, for example, if you get all together and use the power of computing to actually make a change in air pollution, for example, or in the housing crisis, for example. And so I think that there's a lot of very smart people here who have a lot of tools that can see trends and that can help communities. And so I think having a department that just brings all those interests together would be really good.
Yeah, I think those are both great answers, and I agree that we've taken the baby step towards human-centered design and AI, but it's still very much like user experience, singular, and we're getting towards this much broader notion of computing at sort of a society level, society-centered kind of computation. So again, on this sort of thread, you both come from Stanford. Stanford has a very different model of what a kind of computer science department is. I understand you come from design and engineering backgrounds, but that's one model versus CMU has this very distributed kind of giant school of computer science, one of the first in the world, many different departments. What do you think is sort of the relative pros and cons of those two models? Maybe not CMU and Stanford specifically, but sort of the distributed, almost shotgun approach to attacking the frontiers of computer science versus a more kind of cohesive, singular unit of professionals working. So Nick, you want to start?
Yeah, I'll start. I think one of the things that I've noticed and that I value a lot about the way that CMU approaches it with this large, widespread approach is the fact that things here are also super collaborative, and people are basically encouraged to work across kind of disciplinary, even within computer science, right, the disciplinary boundaries, and start coming together. You had asked about what makes a good collaborator. It's such a CMU question as well, because so many people are collaborating with each other. I've already formed a number of collaborations with other faculty members, even in my short time here. And that was like a very easy thing to do. I also think that just the widespread nature of it means that you are exposed to like so many interesting and diverse ideas within computing that it also allows you as an academic and your students to really you could just be at a talk or just be chatting with someone and they're working on something completely different from you. And while I think it's really great to also be around a lot of people who are working on very similar things, because you can get really deep and you can really push in an area, by having that diversity of thought, you can really, I think, expand your thinking. And I'll say I really enjoyed that. That's something I've really enjoyed since I've been here.
Melissa, any thoughts?
Yeah, so I think in terms of pros and cons, I think that the pros of having a department that's mostly focused on one thing is that then you can really focus on that one thing and then be really good at that one thing. However, as Nick said, the pros of having a very wide department is that now you can have so many disciplines and collaborate with so many people. The cons of that might be that maybe some people can fall through the cracks if you don't really understand how to support a specific faculty member who's doing a specific type of research. However, I've very pleasantly found that here everybody is extremely nice. You just have to ask and people will just like help you out. But I do see the cons. I mean, and having been at Stanford, where I was a part of the electrical engineering department and the mechanical engineering department. And so I do see the cons in that there just might not be anybody doing the thing that you want to do. And that's, yeah.
Okay. Another question here is, if someone wants to get involved in your research, whether that be an undergraduate or an industrial partner, how do they reach out to you? How would they be able to get involved in your research vision? So Melissa?
Just email me. I'm very lucky that, yeah, I'm very new. I just started in September, so I'm not getting the 10,000 emails that other people get. So I will reply to you.
And can you comment on how they might get engaged as well? So emails are
Oh,
great.
I'm so sorry.
No, no
Yeah.
need to apologize. So how would a student or an industrial sponsor, how might they engage with your lab?
Wait, what do you mean? Like if they also want to do these research on their own, or if they just want to like?
So let's say, how would someone who's very interested in your research vision and they want to somehow support that vision, whether that be through work or funding, how might they be able to tie into sort of your larger research program?
Well, just email me and we can have a conversation. Yeah.
Fair enough. Okay. Nick, any thoughts on this topic?
Yeah. So from the student level, I heavily leverage our like student postings, like independent study program. I've had actually a lot of independent study students since I've been here. And we work on, like, I basically post project ideas and people reach out with saying, they're interested in it. So for example, I actually have a new idea that I've been working on around supporting creative entrepreneurs and building tools for them. And it's been kind of fun. I've had a bunch of students, both from computer science, but some students from the business school, like who are like, hey, that sounds really cool. And I'm usually generally really excited if someone's motivated and interested and they want to pursue that and start thinking about these ideas. I really like supporting students in doing that. For industry partners, so I've done a lot of work with industry partners. There's a couple of ways in which they can engage with me. Some of them are through just if you're interested in an idea, like there's a gift fund that CMU has, gifts. And I'm really excited by people who maybe even have certain ideas or thoughts about how some of the work that I'm doing could be applied, or they see something and they think that there could be a new exploration for that. And we actually do a lot of work where we are continually kind of talking with those industry contacts and sort of generating ideas with them. I treat these as really collaborative relationships, not just like, cool, thanks for some funding, but like, no, you're providing this amazing resource of, knowledge in the real world, knowledge of practice. The other thing too is that I actually do a lot of collaboration with professional designers and engineers where we're trying to understand their work. So how do they do their work? Where could things be better? And how can we start developing tools to support them in that? And so that's another way that we engage that has been really fruitful and is also great for expanding kind of the research vision of the group.
Okay, well, we're almost out of time. So I'm going to give you one final question and we'll look to the future on this one. So rather than specifically asking, what are you going to be working on in 5 or 10 years? That's kind of amorphous, but a very related question is, what would be a truly surprising development in your field? If you were to go to a conference in 5 or 10 years, maybe it's your lab's paper, maybe it's someone else, what would you have to see that you really go, wow, that's a step function improvement? Because obviously a lot of the research out there is incremental, chipping away at big problems. What would it have to be in terms of haptics or creation or design tools where you realize immediately this was a seminal inflection point? So Melissa, you want to field that?
Sure. I would say I'm gonna answer with two things, if that's okay. One in the haptics realm and one in the education realm.
Of course.
And
Yeah.
so on the education realm, I would say if I saw some sort of teaching method or tool where you could actually, where any student could come in and then learn anything they wanted, like the tool understood how they best learned, how to best teach it to them, and then they could just learn anything they wanted through that tool. That's what I would love to see. And then in the haptics realm, it would be some sort of fake skin that you would put on, and now you're immediately transported into a new world.
Wow, I really hope that happens. That sounds so exciting. Okay, Nick, what are your thoughts?
Yeah, so I think from the design side of things, and I'll take the liberty of doing two things. To the kind of large socio-technical system stuff that I was thinking, kind of long vision and stuff, if we see a project, if we see something where there was a really successful development of a new autonomous technology that was deployed with it at like a city level scale, and it worked, there was real true engagement from the community, the systems actually worked, they worked well, and they actually made serious improvements. To see something like that and to understand the design process that got there, that would be huge. From a deep technology side, I think anything where we start seeing a real shift in kind of automated design generation, where you could say, as a consumer, as someone who's not a designer, actually input somehow into a computer and have a conversation with a computer about a need that you have, a problem that you're having, and that it could actually design a product for you that solved that issue, that would also be huge. Because to go from that understanding and that conversation about what it is that you might be looking for, that you need, to actually coming up with a new product, is this huge area that I still think is going to be mostly, there's going to be people all along there. I think that it's an amazing thing, but if we do see anything that even supports that in a more computationally generative way, that would be huge.
Yeah, well, all those ideas are really exciting, and I hope they come to fruition, and I hope you guys are leading the vanguard. On that note, though, we will end there. Thank you, Professor Martinez, Professor Martellaro, for your time, and thank you for the people that are attending, and thank you for your excellent questions. And we will let this recording go up online once it's captioned and edited, so stay tuned for that. And other than that, thank you again for all your time.
Thank you.
Thanks, everyone.
Bye, everyone.